Indiana University East Physics P120, Physics P125, Energy Use in Cars. Okay, so let's think about cars for a minute. I think we talked about this diagram before, and this is kind of a quick recap. So, what happens to the energy in a car? Well, I think about all of it eventually gets lost to some sort of heat or something, okay? It gets converted eventually into internal energy. But what we consider useful is whatever energy is used to actually move the car. And that's this proportion. So it's about 20%, give or take. Okay? Now, let's think about where we lose energy. The first thing we look at is an engine. Now, we talked about this before. At least for a traditional engine, you have to remember that the maximum efficiency is 1 minus the cool temperature divided by the hot temperature. So, there is a limit to that. So, we lose a significant amount of energy just for thermal reasons. There's also just friction within the engine, and then you don't recover all of the energy anyway. So, some of it goes into heating other things. So, that's that. The other things, of course, smaller things include, well, your gears. Somehow you lose energy to your gears, so gearbox and the drive shaft, etc., etc. You lose some energy there. You also lose some energy in various other things, parasitic losses. So these are things like the water pump, alternator, and heating and cooling your car also counts in that. So the point is, there's a lot of energy that's lost in inverted commas in a car. So how do we evaluate the efficiency of a car? And what we can do is, what is commonly used is what's known as fuel economy. And you see the sticker when you buy a car, okay? If you go to the car lot, at least, you'll see a sticker like this. And here, you will see the number of miles that can be driven per gallon. So that's the miles traveled per gallon of petrol or fuel consumed, based on certain benchmarks. What does that mean? Well, it's a nominal number, okay? So one of the things I'm going to ask you to do in your assignment is actually to look it up for your car. If you don't have a car, look it up for a dream car. So what does that mean in terms of energy? So we have miles per gallon, so we know we can backtrack and say how many gallons are required to drive a mile. But then what happens is that each gallon of fuel you can use to power a certain amount of stuff, right? There's a certain amount of energy they can get out of the combustion. I took this out of the Mackay book. They had kilowatt hours per liter. I'm going to convert it to kilowatt hours per gallon. And we want to calculate the energy required to travel for 1 mile. And then from that, we can actually look at how much energy we use per day, per week, per hour, because we can figure out how many miles we drive. So, for example, if a car has a fuel economy of 26 miles per gallon, how much energy in kilowatt hours is required to travel every mile? So, in 1 mile, okay, and you can travel 26 miles per gallon. So what I'm trying to set up here is that you divide 1 gallon by 26 miles, and then we know that from the previous discussion that there is 37 kilowatt hours of energy per gallon of petrol, and we come out to a number of 1.4 kilowatt hours.